is the linear unit, the first lesson, rate of change. So linear unit part 1, first lesson. The homework that goes along with this is page 2 and 3 in the homework packet. All right, we are going to start by talking about relationships and rate of change. This first lesson is really a lot of review of things that we've done this year, but it's an introduction to linear unit. All right, what makes a relationship proportional? Well, for it to be proportional, we are talking about a graph. It is a straight line through the origin. If we are talking about an equation, it can be represented by y equals kx, where k is the rate of change, unit rate, or constant proportionality. And for something to be a proportional relationship, k has got to be constant. It needs to be the same throughout. Now, Marcus can download 2 songs from the internet each minute. This is shown in the table below. Find the rate of change. Well, our rate of change is k is y over x. Let's see. Now, you can't do 0, 0, but 0, 0 is the origin, but we do not include that when we do y over x, because you can't divide by 0. So if I do y over x, I'm going to have 2 over 1, 4 over 2, 6 over 3, and 8 over 4. Every single one of those is 2, and if I want to put a label on it, it is 2 songs per minute. 2 songs per minute. Is this a proportional relationship? Yes, it is, because it has a constant rate of change. Now, if I want to graph this, our x-axis is our time in minutes. Our y-axis is our songs, number of songs. Let's graph. It goes through 0, 0, then 1, 2, 2, 4, 3, 6, 4, 8. There's my graph. From my table, I'm showing that it's a constant rate of change, that it is proportional by doing y over x. And if I graph it, you can see that the rate of change is 2 songs per minute. And make sure your axes are labeled x and y. Linear relationships are relationships that have a straight line. The rate of change between any 2 points in a linear relationship is constant. And a linear relationship has a constant rate of change. Now, the only difference between just a plain old linear relationship and a proportional relationship is proportional needs to go through the origin. A linear relationship still has a constant rate of change, but it doesn't necessarily go through the origin. So, rate of change can be change in y over change in x. Or, another way to write it is delta y over delta x. The Greek letter delta means change. Well, let's look here. We're going to call this x and y. Let's find our change. What's happening on this left side? Well, for it to go from 170 to 140, aren't I subtracting 30? From 140 to 110, I'm subtracting 30. From 110 to 180, I'm subtracting 30. So my change in my y column is minus 30. What's happening over here? On the x side, I'm going up by 3. I'm going up by 3. I'm going up by 3. So do we have a constant rate of change? Yeah, we do. Because our rate of change is going to be negative 30 over 3. Negative 30 over 3. Negative 30 over 3. That is negative 10 relationship linear? If so, find the constant rate of change. Now, let's look at this. If I drew a line, isn't that linear? Absolutely. Is it linear? Yes, because all of those points are on a straight line. Well, let's find our rate of change. Our rate of change is change in y over change in x. Now I'm going to erase this line so we can see it better. Our change in y, I'm starting here. Always start on the left like you're reading. So I'm going from 80 down to 60 down to 40. So what's my rate of change? My y, I'm going down 20. Down 20, down 20. What's my rate of change or my change in x? From here to here, I'm going over 8. And it's going to be positive because I'm going to the right. Over 8. So my rate of change is, if I divide these both by 4, I'm going to simplify, negative 5 halves. Now, let me tell you about rate of change. You always want it to be written as a fraction. Do not write it as a mixed number. Do not change it as a decimal. Write it as an improper fraction. All right, let's see. Is this linear? I don't know, because you can't just look at it. So let's look at our rate of change. Let's look at y. What's happening on y? So from here to here, I'm subtracting 5. Here I'm subtracting 4. Here I'm subtracting 4. Over on this side, I'm going up by 5, going up by 5, going up by 5. So right away, if I do rate of change is change in y over change in x. Well, my change in y on this side is negative 5 over 5. My next one is negative 4 over 5. Does this have a constant rate of change?